In this section, we're going to look at the proof by contradiction method. The proof by contradiction is used when you have a clause, a proposition, and when you can easily find the negation of the proposition, and if you think that it's easier to go from there as instead. The proof by contradiction is kind of weird because instead of proving the original proposition, we suppose the negation of the proposition, and then we try to prove that. However, because we were trying to prove the original proposition, the negation of the proposition will end up being false and will meet some kind of contradiction, or in other words, will meet an irony or an oxymoron. Um, so this is useful if you think that the original proposition is more difficult to deal with than the negation of it, and ultimately will show that something is wrong about the negation of it. So let's try two example problems here. So the first step we need to do is we need to suppose the negation. So and if you look at the first example, prove that log base of 2 of 3 is irrational. So we're going to suppose that log base of 2 of 3 is rational. So the negation of irrational is rational. So in math, when a number is rational, it means that we can represent the number as a fraction P over Q, where both P and Q are integer values. At this point, we can try to make both sides base of 2, which means that my left-hand side will just become 3, and my right-hand side will become 2 to the power of P over Q. Now we can try to make a power of Q on both sides, and the left-hand side will just become 3 to the power of Q, and the right-hand side becomes 2 to the power of P. Now, one thing that we can tell from here is that both left-hand side and right-hand side, the base 3 and 2, are prime numbers. And a prime number to a power of a integer value will just be a multiple of that prime number, 3. And the same thing for the right-hand side. 2 to the power of p will be a multiple of 2. And I think one easy thing to identify is that the right-hand side is definitely an even number. And the left-hand side will definitely be an odd number because the left-hand side is just odd number multiplied by odd numbers. And the right-hand side is an even number multiplied by even numbers. So we can say that because P and Q are integers, 3 to the power of Q and 2 to the power of P are integers, and 3 to the power of Q is an odd integer, and 2 to the power of P is an even integer. Perhaps I probably should have put that Q will not be a 0 here. And same thing for P, obviously. Well, even if P is 0, no problem, but Q cannot be 0. Therefore, 3 to the power of Q is not equal to 2 to the power of P, because left-hand side is odd and right-hand side is even. Therefore, there is a contradiction. When you're using this method of proof by contradiction, we want to explicitly write down that it is a contradiction, and because we're using the proof by contradiction method. So finally, we can conclude that the original proposition is true by proof by contradiction. All right, so let's try another problem here. For every real number between x and between 0 and pi over 2 inclusive, we have sine of x plus cosine of x greater than or equal to 1. So same thing, we can try to prove that indeed sine of x plus cosine of x is greater than 1, greater than or equal to 1, as it is. But I think we can try to prove by contradiction instead and say, suppose that for every real number x between 0 and power 2 inclusive, we have sine of x plus cosine of x less than 1. The negation of sine of x plus cosine of x is greater than or equal to 1 is sine of x plus cosine of x is less than 1. Now, what do I know about the sine of x and cosine of x for x between 0 and pi over 2? Well, we can think about it in multiple ways, but I think using the unit circle might be the best idea. So between the 0 and pi over 2, which means that we're only looking at the quadrant 1 of the unit circle. So we can try to draw a unit circle like this. And we want to show that, we know that a point on a unit circle has the coordinate, the cosine of x, comma sine of x, right? Where the x is given by the angle from the positive x-axis. And like this, like the diagram here, we're making sure that my angle is between 0 and pi over 2, which is just a quarter of the circle. Apparently, this proposition that we're supposing is that sine of x plus cosine of x is less than 1. Well, is that true? Well, what we can do is we can suggest that, hey, cosine of x and sine of x coordinate, x, y coordinate, means that my cosine of x is my x x coordinate, which is the base of this triangle, and the sine of x is the height of this triangle. And one thing that I can know for sure is that sine of x, cosine squared of x plus sine squared of x is equal to 1. Well, how can we use this to compare this value to sine of x plus cosine of x is less than 1? Well, let's try to go backwards, actually. So I'm going to get to that position. Cosine of x plus sine of x is less than 1. And let's try to square both sides here. Because left-hand side and right-hand side are both squared by both sides. We know that cosine squared of x plus 2 cosine x sine of x plus sine squared of x is still going to be less than 1. 1 squared is 1. But now we know that cosine squared of x plus sine squared of x is equal to 1. Right? So this is a Pythagorean theorem, which means that my left-hand side can be swapped with 1 plus 2 cosine of x sine of x is less than 1. Now, another thing that we know, because we're in the first quadrant, both cosine of x and sine of x are positive values. So it means that cosine of x times sine of x is also positive, which means that 2 cosine of x plus sine of x is positive value. Then basically what we're doing is we're adding a positive value to 1, and we're suggesting that it's less than 1, or in other words, this positive number is less than 0, which is definitely a contradiction. Maybe I can say, since x is between 0 and pi over 2, cos x is greater than 0, sine of x is greater than 0. So we can say that, therefore, cosine of x plus sine of x is less than 1 is contradicted, which proves the point that the original proposition is true, proven by contradiction. All right, so that's the proof by contradiction method. Once again, this method is useful if you think that the negation of the proposition is easy to get, and also it's easier to disprove such negation of the proposition.